Welcome to the DIY Honda Garage channel. DTC P0450 indicates an issue with the fuel tank pressure FTP sensor, specifically that it is out of range. This sensor is responsible for monitoring the pressure inside the fuel tank to prevent excess fuel vapor emissions and enhance fuel efficiency. Positioning of the FTP sensor is typically found on the fuel tank or near the fuel filler neck area of the Honda HR-V, making it crucial for the vehicle's evaporative emission control system, EVAP. This DTC can occur due to a variety of factors, ranging from electrical issues to the sensor itself being faulty. Therefore, accurate troubleshooting is essential to resolve the issue efficiently. The Diagnostic Trouble Code needs to be evaluated using specialized hardware, like the Honda Diagnostic System, HDS, to ensure the best diagnostic results. DTC P0450 is confirmed when the FTP sensor indicates a reading outside established parameters. Particularly, the FTP sensor circuit should show values above 3.62 volts under normal operating conditions. The error may be pending, which means it is not permanently affecting the engine, but has been detected under specific circumstances. The FTP sensor is integral to the vehicle's ECU, or engine control unit, which relies on this information to effectively monitor fuel vapor and pressure. An abnormal reading can lead to poor performance, increased emissions, and potential failed emissions tests. Its location near the fuel tank, or the filler neck, makes access crucial for effective troubleshooting and repairs. Several factors could contribute to the DTC P0450. A failed FTP sensor is often the primary suspect, as its job is crucial for measuring fuel tank pressure. Additionally, poor electrical connections at the sensor or PCM can lead to intermittent signaling issues, triggering the fault code. Damaged wiring within the harness connecting the FTP sensor and the vehicle's computer may also be a culprit that compromises voltage readings or disrupts communication. Lastly, failures associated with the powertrain control module, PCM, itself can manifest similarly if the module misinterprets the sensor data. Understanding and examining these possibilities lay the ground for more refined troubleshooting. Symptoms associated with DTC P0450 primarily influence the vehicle's performance and compliance with emissions regulations. A check engine light illuminates on the dashboard, signaling that the vehicle requires attention. Moreover, you might notice a decrease in fuel efficiency due to improper fuel vapor monitoring, which can lead to unintended evaporative emissions. This malfunction may trigger a failed emissions test, raising regulatory concerns. Additionally, excessive fuel vapor release could pose environmental hazards. Being aware of these symptoms helps prioritize diagnostic efforts and ensures that any faults are resolved in alignment with both performance and environmental standards. In the initial troubleshooting step for DTC P0450, begin by turning the vehicle to the on mode without starting the engine. This is crucial for establishing a baseline condition. After this, use the Honda Diagnostic System, HDS, to clear the stored DTC, allowing for a fresh diagnostic evaluation. Once cleared, shift the vehicle back to the off/lock mode and proceed to remove the fuel fill cap. This step helps in ensuring that any pressure variations are appropriately assessed. Next, turn the vehicle back to the on mode and utilize the HDS to check the FTP sensor parameters. Evaluate whether the sensor voltage remains above the threshold of 3.62 volts, as outlined in the diagnostic procedures. After assessing the initial conditions, the next step requires you to reinstall the fuel fill cap securely to ensure the integrity of the fuel system. Then, start the engine and maintain the RPM at around 3,000 without any load. This elevated engine speed helps in engaging system responses necessary for accurate diagnostics. During this phase, monitor the OBD status using the HDS specifically for DTC P0450. If the HDS reads failed, it confirms that the issue persists. In contrast, if it indicates passed, this may suggest an intermittent issue that should be closely examined for poor connections or loose terminals associated with both the FTP sensor and the PCM. For troubleshooting step 3, commence by turning the vehicle to the off lock mode. This is necessary for safely disconnecting electrical components. Disconnect the FTP sensor's 3P connector, which is integral to gaining access to its signal circuitry. Next, utilize a jumper wire to connect terminals A and B of the FTP sensor's connector. This act establishes a direct communication pathway with the vehicle's system. Turn the vehicle back to the on mode and utilize the HDS to check the FTP sensor parameters again. Evaluate whether the sensor voltage is now greater than 3.62 volts. If it aligns with the malfunction threshold, proceed to the next step. For troubleshooting step 4, again, start by shifting the vehicle to the off lock mode for safety. After this, remove the jumper wire previously used for testing to return the circuit to its original state. Turn the vehicle back to the on mode and measure the voltage between the designated test points indicated in the diagnostic procedure. Specifically, voltage should be approximately 5.0 volts under normal operating conditions. This measured voltage is critical for confirming proper sensor operation and establishing if the wiring harness is intact. If the voltage reading does not meet the expected value, the issue may lie elsewhere in the wiring or sensor circuit. In step 5, start by turning the vehicle to the off lock mode once more, ensuring safety while performing electrical diagnostics. Jump the SCS line using the HDS and allow a pause of more than 1 minute for the system to stabilize. Afterward, disconnect the PCM connector A51P. Doing so will help isolate the PCM from the system. Connect terminals A and B using a jumper wire, specifying the resistance in the circuit. By measuring resistance between specific test points, it is critical to note whether the resistance is at 1 ohm or less. Achieving this low resistance means the wiring is likely not damaged, and further diagnostics should be performed in line with the vehicle's service information. For the final troubleshooting step, again, set the vehicle to the off lock mode. Perform the SCS line jump as previously done in step 5 and wait for over a minute for system stability. To effectively isolate wiring issues, disconnect the PCM connector A51P and use jumper wires to connect the necessary terminals. This facilitates the measuring of resistance between the specific test points. Similar to previous steps, if the resistance measures at 1 ohm or less, this indicates that the wiring is intact and no immediate repair is needed in that area. Should the resistance exceed this value, appropriate action must be taken to repair any open circuits present. Once the necessary repairs are accomplished, it's crucial to conduct a final verification to ensure that DTC P0450 has been resolved. Start by clearing any stored Diagnostic Trouble Codes, DTCs, using the HDS to refresh the system. Following this, perform a test drive under varied operating conditions to effectively evaluate side effects that may have gone unnoticed previously. Monitor the dashboard for any reoccurrence of the check engine light. If the code does not reappear, it indicates that the original problem has been rectified. Verifying this closing step helps guarantee that the vehicle can operate normally and is less likely to experience repeat issues related to the FTP sensor. Conducting regular preventive maintenance is essential for avoiding DTC P0450 and similar issues in the future. Frequent vehicle inspections can detect small issues before they escalate, saving time and money. Periodically check the FTP sensor, ensuring connections are tight and wiring remains intact. Any fraying or damage should be repaired immediately. Additionally, always ensure that the fuel fill cap is tightened correctly to prevent leaks. Adopting these preventive measures not only extends the lifespan of the FTP sensor and associated components, but also significantly enhances the overall performance and efficiency of the vehicle, ensuring it meets emission standards consistently. In summary, understanding DTC P0450 and its implications is vital for maintaining the proper function of the Honda HR-V's engine and emissions control systems. Following the standardized diagnostic protocol allows technicians to pinpoint the issue methodically. Addressing the potential causes, ranging from sensor failures to wiring issues, ensures that solutions are effective and reduce the likelihood of reoccurrence. Finally, verifying field repairs through extensive testing confirms that the system operates within the required specifications. The combination of these practices not only supports immediate rectification, but also promotes long-term vehicle health, environmental compliance, and customer satisfaction. Please like and subscribe to the channel. See you next time.